absolute value equations. We're going to give a little background information. We're going to talk about solving them. We're going to have some things to look out for, and then we're going to do an ugly looking double absolute value. Welcome to Mark's Math Methods. So some background and theory behind the technique. So if I asked you to evaluate the absolute value of 3 or the absolute value of -3, absolute value is what is absolute value? Value is distance from 0 on a number line. So 3 is 3 units from 0, and it will always be non-negative. And -3 is also 3 units. So the absolute value of 3 is 3, and the absolute value of -3 is also 3. Again, absolute value will always be non-negative. So if I asked you to solve for x, the absolute value of x is 3. Well, we know it's 3 and -3, because the absolute value of 3 is 3 and the absolute value of -3 is 3. And that's the pattern we're going to use as we go through these. So let's replace the x with an expression in y. So I'm going to say the absolute value of y minus 7 equals 3. We're going to follow this pattern. So we end up with the inside equals 3, and then the inside equals the opposite of 3, -3. So once we get the absolute value isolated, which it is, we split it apart into 2 parts, then we solve each part individually. So we end up with 10 and 4. The left one is 10 and the right one is 4 by adding 7 in this case. Notice 2 things. The inside doesn't change. And all we do for the second part is we change the sign. And you always want to check your answers. So if I plug in 10 for y, I get 3 equals 3. I get a true statement, so it checks. And if I plug in 4 for the y, I also get a true statement, so they check. You always want to check your absolute value solutions. So let's look at this one. The absolute value of 2x minus 7 minus 3 equals 8. First, we need to isolate the absolute value sign. So that means we need to get the absolute value sign by itself on one side. So we need to move the 3 over. And now that we've got the absolute value sign all by itself, now we can split it into its 2 parts. The first part is what you see as if the absolute value signs are not there. And the second part, the inside does not change. We just change the sign on the other side. And then we just go through and solve them individually. So on the left one here, I would add 7 to both sides, and I would divide by 2, and I get x equals 9. On the right one, I add 7 to both sides, I divide by 2, and I get x equals -2. Now we should check them. So using x is 9, we get a true statement, and using x equals -2, we also get a true statement, just by plugging those values in and doing the arithmetic. So we had to first isolate the absolute value sign and then split it apart into its 2 parts. The first part, just imagine the absolute value sign is not there. And on the second part, the inside does not change. We just change the sign on the opposite side. We solve them individually, and then we check our answers individually. Here's one a little more complex. 2 times the absolute value of 3x plus 9 minus 6 equals 0. So I need to isolate the absolute value sign. So I'm going to add the 6 over, and then I'm going to divide by the 2. So the absolute value sign is all by itself. And now I can split it apart into its two parts. The first part as if the absolute value signs are not there. And the second part, the inside does not change, I just change the sign. Solve them individually. So on the left one, I got x is -2. And on the right one, I got x is -4. And then, of course, we should check them. Plugging in -2 first, and then plugging in -4. And in this case, I get a true statement, so it checks. And that's how we can check our answers. Plug it in, does it make it true? All right, here's two things to look out for. This is the first one. The absolute value of x plus 5 equals 0. So once isolated, does it equal 0? Doesn't matter how we start, but once we get it isolated, does it equal 0? If that happens, well, let's follow the rules, see what happens. What is -0? Oh, that's the same as 0. So the two sides are the same. So we only get one answer, and it comes from this side. So in this case, x would be -5. So if the absolute value equals 0, you're only going to get one answer instead of two. Okay. Here's one. The absolute value of x minus 5 equals -3. Once isolated, does it equal a negative? Well, the definition of absolute value is distance from 0, and it will always be non-negative. So as soon as it equals a negative, it can't be. But let's work it as if we could do it. See what happens. So I split it apart into its two parts. I get -8 and -2. I didn't show all the work here. And you can see that if I check it, neither one works. So you can do the work and you can get answers. But if you don't check it or don't realize that the absolute value can't be equal to a negative, you're going to have the wrong answers because neither one of these answers checked. So even if you forget that the absolute value cannot equal a negative, make sure you check your answers. Let's look at an ugly looking double absolute value. The absolute value of 3x minus 9 equals the absolute value of x plus 5. Well, the first one, the one on the left, is already isolated, so we're good. Now we'll split it apart into its two parts. The one on the left is what you see without any absolute value signs. And the one on the right, the inside does not change, but I need to change the sign in front of that second absolute value. So I need to think of it in parentheses. So negative, and then I put parentheses for the other inside. Let's solve the one on the left. And we get x equals 7. If we solve the one on the right, first remove the parentheses and then go through its process. We get x equals 1. And we should check these. And they both check. I hope the presentation was helpful. thumbs up, subscribe, comment. And if you have any problem types you'd like me to demonstrate, there's my address.